Welcome to qnawire.
We have C7H11NO, and we need to draw 3 amides having this formula. Well, what is an amide? Recall that an amide is a carbon doubly bound to oxygen and singly bound to a nitrogen. And then we can put whatever we want over here, and this nitrogen can also have, it'll have to have 3 bonds, either to hydrogen or carbon or what have you. Okay, so this is the general form of an amide. Note that all amides have a degree of unsaturation of at least 1, right? We've got a single double bond. Okay, so it may be wise to calculate the degree of unsaturation of the formula we're given to determine if we need any additional double bonds or rings, right? So what is the degree of unsaturation of the formula we've been given? Well, what is the formula for degree of unsaturation? It's the number of carbons divided by 2 minus the number of hydrogens divided by 2. Right? Minus the number of halogens divided by 2. We don't have any halogens. Plus the number of nitrogens divided by 2, which in this case is 1. And oxygen is not in the formula. It won't affect our degree of unsaturation. Okay, so what do we get? Sorry, we do not divide the carbons by 2. I'm just going to erase that here. My mistake. I thought that looked funny. Simply the number of carbons, right? Okay. So let's check this out. We've got 7 minus what's 11 divided by 2? That's 5.5. And what's 1/2? That's 0.5. Okay. So this is going to be 7 plus 1/2. That's 7.5 minus 5.5. That's 2. Right, so we see that we do have a degree of unsaturation of 2, which means that any amide we draw with this formula is going to need to have an additional double bond or ring. Yeah, so we'll just keep that in mind. So let's just draw a couple and then we'll get to naming them. So to keep things simple, we can simply note that this basic amide has 1 carbon, 1 oxygen, and 1 nitrogen. We don't need to worry about the hydrogens because those will take care of themselves so long as we adhere to having a degree of unsaturation of 2, right? So essentially we just have 6 carbons to play around with. So we can say, okay, double bond to oxygen, nitrogen. Let's put a methyl here, a methyl here. That's 3 of our carbons. Then we can put the remaining 4, 1, 2, 3, 4 here, and add a double bond. Oh, I don't know, here, right? 1, 2, 3, 4, 5, 6, 7 carbons, 1 nitrogen, 1 oxygen, and the hydrogens are guaranteed to be correct because we have the degree of unsaturation of 2. Okay, so here's one amide. We could do something similar where we extend one of these chains on the nitrogen. Let's make this an ethyl group and a methyl group. Okay, and then we can put our double bond still here. Okay, and then, I don't know, we could maybe try doing something with like a ring structure, like a cyclopropane. Let's do that. This is 1, 2, 3, 4. Maybe we'll get fancy here and put I don't know, a hydrogen and then an ethyl here. 1, 2, 3, 4, 5, 6, 7. Yeah, that looks good. Okay, let's get to naming these. So the first thing that we're going to do is number this, and that is essentially we number the carbonyl carbon as 1, 2, 3, 4, 5, and then we'll recognize what our functional group is here. And so this is going to be the root name of this is going to be a N, right? Because we have a double bond, a pent-N amide, right? Pent, and then the double bond is on 2, so a pent-2N amide. Okay, that's the root name. And that comes from 1, 2, 3, 4, 5, and the fact that it's an amide with a double bond on carbon 2. It's a pent-2N amide, right? And then we indicate the nitrogen functional group by saying that this is an N-N dimethyl. N, comma, N dash dimethyl, right? So we treat that as a functional group. With no numbering because it's assumed that it's going to be attached to the carbonyl carbon, right? And the only remaining thing left is that we've got to indicate that this double bond is E, right? It's E because the most important groups are on opposite sides of the double bond. Okay, so altogether then, that this would be E dash N, comma, N dash dimethyl pent 2 N amide. If we didn't have the amide, if we didn't have the double bond, this would be an. Okay. Let's move on to the next. Very similar here. Once again, this is E, but now our chain is only 1, 2, 3, 4 carbons long, and we've got an N ethyl and methyl. In either case, this becomes a but-N amide or a but-2N amide, right? But we still have this E out front. E, and then since we have different groups on our nitrogen, instead of saying N dimethyl, we will put them in alphabetical order and do them one at a time. That is N dash ethyl dash N dash methyl, right? So it's just like any other functional group, like 4-chloro. It's just we're saying N-ethyl, you know? It's like we just treat them as functional groups that are on position N. We specify N instead of a number. Okay, N-ethyl, N-methyl, and then but, still 2N amide. Okay, final one here. Basically, we will, because amides have a higher priority in terms of naming than cyclopropyls, we basically just treat this cyclopropyl as a functional group on position 1, 2, 3, right? So this would be a 3-cyclopropyl propanamide. Propanamide because it's 1, 2, 3. And then the other unique thing is that we now have a hydrogen on this nitrogen, right? Whereas before we had to specify N-methyl or N-ethyl. Hydrogens are assumed, so if we don't specify any hydrogen, it's just assumed there. So there will not be an N-hydrogen or something in the name. We'll just have the N-ethyl, and the lack of an N anything else will imply the hydrogen's existence, right? So again, we have this functional group, 3-cyclopropyl. That will come before the N alphabetically. Rather, before ethyl alphabetically, right? Because we know this is going to be N-ethyl. So we'll start with 3. Cyclopropyl, right? Then this is just a functional group, right? At position N, that's N-ethyl, N-ethyl. And then we know it's a propanamide now, right? Propane because it's a 3-carbon chain. Propanamide. And that's it. Okay, so here's 3 different amides that have that formula and how you might name them.